All right, I think we're ready to start. Carrie, do you think you could please close the door, or Miriam? Thank you. So I'd just like to welcome you to Max Planck Florida Institute for Neuroscience. My name is Anna Fiallos, and I am the head of education outreach. And Max Planck, or this Max Planck, is part of a research society, and they're mostly based in Germany, and each institute has a research focus. And in total, we have institutes that dedicate basic research to the arts and sciences. Does anyone know who Max Planck was? Just quizzing you already, minute one. So Max Planck, oh, I know who might know. Philip, where are you? There you are. No? Okay. Exactly. See? I did get to know you over the 6 weeks. Yeah, so Max Planck was a physicist. He won the Nobel Prize in 1912 or 1918, and so we're named after him. Our particular research focus is neural circuits, so we do brain research here. And up here we have a slice through our scientists in terms of career path. And my department is dedicated to inspiring and educating the public about the brain and about careers in science in general. So that's the mission of today's event. It's to get you sort of thinking about, what is science? What is a career in science? What does a scientist look like? What are their day-to-day lives like? And this is just a forum to allow you to ask questions in terms of there are no dumb questions. So anything that you've ever thought of, like how do you end up being a scientist, or what did you major in college? All those things. This is your chance to ask those burning questions. And so I think we are going to start with the scientists themselves introducing their names, who they are, where they've studied, and what they do currently. So I'll start with the senior member of the panel, uh, Dr. James Schumers. Can you tell us about yourself with the microphone?
I'll use the microphone. Okay. So I'll just give you a brief glimpse of sort of my trajectory, my career of what, specifically educationally I went through to get to this point in my career. Right now, my position here is as a research group leader, which means I run one of the labs here. So I get to choose a research topic. I hire the scientists into the lab. I train the students in the lab. I oversee all of the operations of one laboratory. And there are, I guess, 8 labs here, and each person is in a different one of them. And I started off, I just want to say this. When I was your guys' age, I was not thinking about my career. I was not at any career panels. I don't know, we didn't have video games back then, but I was, doing the equivalent of video games at home. So you guys are a step ahead of me. But basically how I got to where I am is I started off, went to college. I didn't really know what I wanted to do. I went to a small liberal arts college in Ohio, Oberlin College. I wanted to probably study science, but I didn't really know. I took philosophy. I took, all kinds of different classes. I was not like laser focused on being a scientist from that point on. But I took one neuroscience class with a professor that I really liked, and I sort of got hooked. And then he let me do some research in his lab, and that got me even more hooked. So then when I graduated from college, I took a position as a research technician in a lab, and I sort of thought, I think I like research, I think I like neuroscience, but I don't want to commit to graduate school or something like that until I really get to try it on a day-to-day basis. So I took a job for about a year and a half as a technician, and then I decided this is the career for me. I really like research, so I applied to graduate school. And so then I was accepted into a number of programs, and I chose to go to MIT, and I was there for for graduate school and finished my PhD there in neuroscience. And then I decided to stay there for further training as a postdoctoral fellow. And then from there, I moved on to here. So what you're going to hear as we go down the row here is the viewpoint of someone at each of those stages that I just mentioned to you. Someone who's a technician, someone who's a graduate student, someone who's a postdoctoral fellow. So you'll get to ask them and hear about their sort of day-to-day experience, but that is the sort of standard trajectory to go through in academic research. Now, I'm at this institute, which is a pretty rare type of institute in the United States. Most typically, someone in my position who had gone through this trajectory would be an assistant professor at a university who would do some combination of running a research lab and teaching. It's very similar here, except that I don't do any teaching. I'm devoted full-time to running a research lab. So, if I had to sort of look back on what were the turning points that got me to here, as I mentioned, I was not the super laser focused, this is what I want to do, I'm going to be a scientist kind of person. But each step along the way, in high school and then in college and then in graduate school, it was having one professor that I or teacher that I just clicked with and got along with and engaged with them, and they inspired me and made me think, this is cool, I want to do this. And, for me, I just didn't have, a history teacher that did that for me, but I had a biology teacher in high school, and then I had, a neuroscience professor in college, and it was those sort of inspirational moments of those people acting as mentors that really got me, hooked on it and enabled me, I think, to succeed at each step along the way. So that's a little bit of my trajectory. You'll be able to ask questions later, but I think I'll hand it over to Joe.
Yes, please speak into the mic because we're recording it.
So I'm Joe Schumacher. I'm a postdoctoral fellow in David Fitzpatrick's lab here at MPFI. So a postdoc, for those of you who don't know, is kind of like the guy that James hires to do research in his lab. So along with grad students like Sunny. My job is essentially focused on one sub-project that is in the theme of the lab. So our lab studies visual cortical processing, and I do one project that explores the role of visual cortical processing. There's a lot of different ways you can study that problem, and I have my own project, and other postdocs in the lab have their own projects. I guess I would say a lot of the same things as James. When I was in high school, I had no idea what I wanted to do with my life. I kind of did poorly in science a little bit. I liked biology. I was terrible at chemistry, and I liked math. And I actually, for a long time, had a hard time figuring out what I was going to do career-wise. But in college, I sort of found myself in situations with certain mentors who really just sort of steered me in one direction or another, or introduced an interesting question to me that I wanted to pursue. So I also went to a small liberal arts college but mine is in New York. It's called Vassar College. There is a neuroscience program at Vassar. I did not major in neuroscience. I majored in computer science and psychology. And I did a thesis studying robots. I built robots that did little tasks and competed with each other for evolutionary purposes, basically. We tried to evolve robots. And the reason that I decided to try to get into neuroscience was I really liked the experience of doing research. I really liked building things, working with my hands, designing experiments to test out specific questions. But at the end of college, I was kind of not sure where I would go with the robot thing. And I joined a lab in New York City as just a technician. It was a Parkinson's lab that studied motor control in Parkinson's patients. And that was at Columbia University, where I ended up doing my PhD. I applied to a few grad schools, but Columbia was, I had met people there, and it was probably the best program I got into, so I went there. And yeah, so I feel like I haven't always had a lot of career trajectory. Like I haven't always felt like I knew exactly what I was doing, but I kind of just like moved from one thing to the next, and it all kind of, in retrospect, seems like a seamless trajectory to get to being a researcher. But yeah, so it's,
They have their own.
Hi, my name is Sunny. I had my education in China until I got into college. So my college was still in China in Wuhan University. I think the situation there. I think the situation there could be a little bit different from here. I don't know how you choose your major in college, but in China, we don't have this type of discussion for the high school students to let them know more about their choices. We more focus on the study, the scores, and everything that could send you into a good college. And then by the time you're sending out your decisions, you have by my time, we have three choices that we can fill in the form, the three majors we are interested in. And by the time I have actually no idea about science, how science works is actually working. I have no idea about like even others like management or business, whatever. I have no ideas. So I just choose the ones that I think I would be good at, and I got admitted in biology. And after like um, studying in this field for several years, I feel myself good at it, and I like to continue this path. So I decided to go on to do graduate work. And so that's the time I applied to study in graduate school in the United States. And I was lucky to be admitted by the University of Texas, MD Anderson, for some cancer research. I did it there and got a master for 3 years. So then there is a little bit switch, change of direction. So I moved to neuroscience. They're both biology. Not that much difference. I have my personal reason why I have to switch from cancer to neuroscience. It's because my husband got a postdoc position here in Florida. I want to move in to Florida to be together with him. So here, the best subjects in this region is neuroscience. And I also think that cancer biology, well, we have already deposited a lot into the study about the mechanisms and about how to cure the patients and everything. It is going well, but I feel more of the work should be applied to clinics for the doctors, I mean, for the medical doctors to do. The basic research part, many of them has been done. But for neuroscience, it has a longer way to go. We don't know that much about how our brain functions in detail. So I switched here and got admitted to Dr. Ryohei Yasuda's lab as a graduate student. So our lab major focus on understanding how the molecules are work inside of our brain at a position where your neurons are connect with each other and transmit signaling between each other. And my project is to resolve the images there on the nanometer scale by electron microscope and to see what is happening there.
Thank you.
Hello, everyone. My name is Conan Thomas. I am a research technician in the electron microscopy lab. So I do similar things to what Sunny does, but I work for the electron microscopy lab instead of using electron microscopy. So Sunny works in one of the labs here, but I work in the core facility is what it's called. So I'll start off with my history. So I started, first of all, I didn't know that I would like science when I was in middle school. I was failing most of my classes, actually. I didn't think I was a smart kid. But then when I got to high school, I got placed in honors science. So at that point, I thought, maybe I'm good at science. So that's when I started getting interested in science and taking more classes. And that's when I got interested in biology and also environmental science. So then I continued on to my undergraduate degree at the State University of New York College of Environmental Science and Forestry. And that's where I studied conservation biology. So that's nothing related to what I'm doing now. But towards the end of my career there, my courses there, I learned about this technique of imaging things called electron microscopy. And actually, I didn't figure that out until a couple of years ago. And when I saw that, I thought, this is so freaking cool. I want to do this. So I took classes. I talked with the professor about, the field, and I learned a lot. And from there, when it was my senior year of college, I decided, well, I could either go on to my PhD, I could get an internship, or maybe I could try getting a job in this field as maybe like a technician or something. So I applied to Max Planck. I did not expect to get an interview, let alone the job, but I got offered the position. And from there, I had no background in neuroscience whatsoever. I think that's one of the difficulties of my path. But I want to emphasize to you guys that what you major in college is not necessarily going to be what you end up doing. Most cases, it's not. So you might focus on chemistry, maybe. And then when you graduate, you might say, okay, maybe I'm interested in neuroscience, so I can apply this knowledge I have in chemistry and use that in neuroscience. So that's what a lot of people actually end up doing. Yeah. So that's where I am now today. I'm a technician.
Well, thanks for introducing yourselves. And that's actually kind of neat about neuroscience. Neuroscience is pretty interdisciplinary. And so, for example, Dr. Yasuda, the lab that Sunny's in, he's a physicist, right? And he's doing neuroscience. And there's many examples. Like we have a chemist who is working in a machine shop. So that's another unusual career path for her. So I think that's a good point to make. So moving on to, so this is a chance for you guys to ask questions, but I have some tailored questions to get, the conversation going. But a question that has popped into my head that I didn't have pre-written that has emerged from hearing you guys is two panelists said that when you were young, you were not doing well in science. So I was just wondering, what do you think turned it around for you? What do you think changed that made it go from science is something I'm not good at to, hey, science is something that I am good at? Joe? Well, from both of you. I was wondering from both of you.
I don't know. I think that a big part of it was I thought that, this is no offense to any teachers in the room or whatever. I just thought that high school was really boring. I thought that I didn't like how regimented it was. I didn't like how textbook it was. It didn't feel like there was any room for creativity or free expression of thought. It was just sort of like learn how to do math well, and I was really hoping that my life wouldn't depend on a bunch of stuff that I was learning in high school, and it turns out actually what you learn in high school is very important, because if you don't make the most of the opportunities you have in high school, it sort of narrows your opportunities later on. But the thing that sort of turned me on to science later was understanding that it's not really just a book of facts and learning a bunch of stuff, but it's a process of figuring things out and telling a story through data. So I just was not particular. Maybe I went to a crappy high school. I don't know. But yeah, I think your attitude changes as you get older. You start to care about things that you didn't really care about before. You start to take things a little bit more seriously sometimes. I don't know. I kind of grew up a little bit at one point.
All right. Maybe. So late bloomer.
I think for me, when I was in middle school, I just didn't think think I was good at anything. And then once I got to high school, I was put into this program, and then I realized that I could actually do something specifically that I was good at. So then I sort of got hooked onto it, and I wanted to know more about it, and I was really interested. I started getting really interested in science. So it was that inspiration of, realizing that you're smart.
Yeah, I get that. All right. Well, to get the conversation going, I've written a question for each panelist, and then I'll open up the floor to you guys. So I'll start with James. All right. As a principal investigator, you've reached a stage in your career where you are an independent researcher, and you mentor young scientists in your lab. So you've already told us the career path that you took to get there, but your lab focuses on a question. You study the visual system. How do you go about, like, in all that training that you've done, how do you choose a topic that you're going to dedicate your career to? How do you say, I want to work on this problem for, I don't know, many years.
Many years.
many years.
Science is slow. So, my overall fascination, the reason that I study neuroscience, to be quite blunt, is because it's the most fascinating thing to me that there is. It's not like I'm going to cure Alzheimer's because I have a grandmother that had Alzheimer's, or those, one of those kind of stories. I do it because of the pure joy and wonder of trying to understand the brain. And so to me, when you think about what does your brain do for you, it does a lot of amazing things, but every single minute of every single day while we're awake, we're seeing, and a lot of how we interact with the world is through seeing. So of all the questions that are reasonably approachable, some of them are not. I'd love to be able to study how do we have consciousness, or how do we have moral reasoning, or how does the brain produce language. But honestly, the field is not at a point where we can answer those questions very well. But vision is sort of something that we can approach. It's reasonable to do experiments where we can put up a visual stimulus and see what happens in the brain. And it's a really important part of our lives. We're visual creatures, and so if we can even start to approach understanding that, that gives me satisfaction.
All right, thank you. Joe, so you have a PhD in neurobiology and behavior, and right now you're a postdoc. Can you tell us what that means? What does it mean to be doing a postdoc? And can you tell us how you chose to do that training here at MPFI, at Max Planck?
Let's see. So I spent so much time during grad school thinking about my research that I didn't really think about my career. So when I got to the end and I had my dissertation written, the next logical step seemed to be to just keep doing research. I didn't really occur to me that I would maybe go off and do there are a lot of things you can do with a PhD. You don't have to become a postdoc. I think that the reason for doing a postdoc has sort of changed. Maybe this is sort of talking shop a little too much, but I have this impression, and maybe this is a total fantasy, but 20 years ago, I don't think everybody had to do postdocs before they did faculty positions. I think they just handed out faculty positions at universities like candy on Halloween if you had a PhD. And the truth is, getting positions like that, getting to James's stage, is extremely competitive, and it's there's a bottleneck, and to fill that bottleneck, I think, and there are good reasons to do a postdoc too, like the fact that maybe you finish your PhD and you've mastered some type of recording technique like electrophysiology or something like that, but you don't feel like you have like a full understanding of molecular biology, or you spent so much time making computer models of the brain that you never really gained expertise in how to do physiology or wet lab stuff. I think the postdoc offers you an opportunity to sort of shift gears a little bit, get a little bit more expertise in a broader range of techniques and research questions, so that when you are ready to have a faculty position, if that's your goal, then you can employ people to do a wide variety of things and be, well equipped to advise them and stuff like that. So I chose MPFI to do my postdoc. I don't know why. I mean, I think the reason why was I wanted to learn a technique that is kind of bread and butter here, which is 2-photon calcium imaging. And I'd heard a rumor that everybody in David Fitzpatrick's lab gets a 2-photon rig. And that was appealing to me. And the first time I heard about MPFI when I was in grad school, I looked it up on Google Maps, and it was just surrounded by golf courses. It seemed like maybe it was a retirement home for neuroscientists. Bert Sockman was sort of, getting to the age where maybe that could be true. So I thought it was really weird when I first heard about it, and then I came down and interviewed with David, and I was just totally blown away by the resources here. The people here are extremely smart. It's a beautiful building that doesn't hurt, and the types of questions that David is asking in his lab were exactly where I wanted to go with my research. So I think it was just a good fit. It was also nice to get out of the university setting. Like, this is a pretty unusual research environment, and I was just kind of intrigued to see what research would be like unhindered by bureaucracy. So that's one of the reasons it's cool here, and that's why I came here. Did I answer all those questions?
I think so.
Okay.
I mean, essentially, you're doing a postdoc because you're trying to get more training.
Yeah.
Right.
Yeah.
Sure. Specialize.
Yeah. Good. Good.
All right, Sunny. So you're a graduate student. That means you're working towards getting your PhD in Dr. Yasuda's lab. When you were applying for graduate schools, did you ever consider any other career options? Did you think about, med school or law school or business or anything like that? Or did you know, like, this is what I want to do?
Like Conan just mentioned, that your college major doesn't have to decide what you do in the future. I've seen some of my classmates switch their path after graduation from college. They go into the business field, become marketing manager or something. So I have seen those examples. But for me, it's different. I have learned biology for 4 years in college, and I had an intern in a neuroscience lab by that time. So I have do my research to find out what I can do if I keep myself in the science field, and I like those futures. So I actually didn't consider other options when I apply for graduate school. I want to stay in science.
Okay. Thank you. So Conan, so you recently, graduated from college, 2015. You're a youngin'.
Yes, I am.
And you've been working in the electron microscopy core. How has that experience influenced you in terms of, has it inspired you to consider further training in the future?
Yeah, so I'll start with before I came here. Probably about a month before I came here, I did not know that I was going to be here. I thought maybe I would do an internship or, get a maybe do my PhD, but probably not. So then I came here, and I had no training in neuroscience, and that was terrifying because people here are very smart. So you kind of feel like you need to learn very quickly and that sort of thing. But I feel like, so I've only been here for about 1.5 years now, and I feel like I've learned so much information because I'm constantly reading, I'm working every day, I'm immersed in neuroscience, so I've learned a lot, and I didn't think that I could do that before. So now I'm much more confident if I wanted to go onto my PhD, and actually that's something I'm definitely considering in the next couple of years. So that's definitely helped me make that decision.
Great. Actually, I kind of was, thinking just when you were speaking about what you major in college is and what you do. So your major was conservation biology. Do you feel it seems, like biology, I don't know, neuroscience, right? Is it applicable? Do you feel like, hey, those 4 years are
So
are
first of all,
handy?
no regrets. Second of all, I feel like I learned a lot about becoming a scientist. Because that's what I studied biology, still science. There's definitely some similarities between neuroscience and conservation biology and ecology. So yeah.
The question is it like what is conservation biology actually?
Yeah. First of all, yeah. So
Right,
it's like
sorry, let's start with that.
Yeah. First of all, conservation biology is like a mix between environmental science and biology. So I was actually studying insect ecology, so how insects interact with their environment and things like that. So in that sense, I cannot apply that at all to what I do today, other than sometimes I work with flies, fly brains.
I see. Okay.
That's about it. But that's okay for me. I mean, that got me excited about science. That got me inspired to study what I'm studying now. So.
Okay. All right. So we've reached the point where now we're ready to hear what you guys want to talk about. So we have a microphone right there. So if we could form a line, if you're inspired to ask a question, please find the microphone and we welcome your questions. Oh, maybe you can tell us, your name and your school, and then if you want to direct your question to a particular scientist, feel free to do that.
My name is Jonathan Springer. I'm from Santa Lucia's. Yeah, Miss Sun, right? Why did you do your studies in America? Do you feel you have greater opportunities here than China?
I do this is because, well, first of all, in science field, you have to do a PhD. Graduate school is necessary for you to stay in the field of science because in college you are learning, but for PhD you are discovering new things. You are making. So for science, it's different from other field, and the PhD training in American is better than what we have in China, at least for most of the universities. Well, here is better. That's why I come here.
Yeah. Mr. James, what advice would you have for a young aspiring scientist? What advice would you give now with the experience and knowledge you have now to someone our age, for example?
I think a couple of us have sort of alluded to this. The best advice that I can give, and I'll break it into two things. One is follow your passion. Do what is exciting to you, not what you think is the best thing to get into medical school or whatever. If it's, conservation biology, do it. You can still get into medical school if you do conservation biology well and you impress the people and you show the world that you can dedicate yourself to something that you're passionate about and do it well. That's what matters when you're getting accepted into someplace or getting hired someplace, is being able to show that. So that's my first piece of advice. And the second piece of advice is, if you have the opportunity to find if there is someone who inspires you, like a mentor, stick to that person. Make sure they know that you are looking up to them and looking to them for advice, and let them guide you, and let their inspiration rub off on you.
Yeah.
That's my best advice.
Yeah. Can I ask you a question about like research about something about neuroscience?
Yeah, I think maybe one more question,
Yeah.
and then we'll let some others after this one.
You want someone else to go right now?
No, go ahead. Go ahead.
Oh, like how far have you come along in understanding heredity with the brain disorders, for example, like the Parkinson's and the Alzheimer's?
Right. So, I don't particularly study any of those topics in my research, and neither is there very much of that at this institute. But there's no single answer to that. So different disorders are much more heritable than other disorders. Some of them are very clear. Huntington's is an example. The gene is identified. You know if you have that, you're going to have that disease. Other things like Alzheimer's, it's you guys, someone may know more about it than me, but it's very unclear how strongly hereditary it is, and it's still a lot of ongoing research on that.
Thank you, Mr. Damien. Miss.
This is a research type question. Do things in space affect the brain? And if so, what?
Can I take a stab? So, what do you mean by space? Do you mean outer space, or do you mean just like space, like around you?
Like outer space.
Well, I know they sent a chimp into outer space and it came back and it was okay, and that's about the extent of of what I know about that. I think when you send like astronauts to to like the space station and stuff like that, they do a lot of they're constantly like getting a physical. They're constantly measuring their vitals and like all this stuff to see how prolonged exposure in outer space can affect that. They bring like ant colonies and frogs and stuff into space to see how they'll survive in like artificial gravity, or not artificial gravity, but like in Earth's orbit and stuff. But I don't know that there's. I can't think of a lab that has that question as their central focus. But so that's low-hanging fruit. That means you can go out and do that yourself if you want.
Thank you.
Hi. My question is also about science. It's do you guys think that we will ever be able to guide axons in the vivo through the spinal cord to manipulate other cell functions? Okay. Do you think we will?
We need to think. We're stalling for time.
Do you think we will ever be able to guide axons in the vivo through the spinal cord to manipulate other cell functions?
I think he's saying in vivo.
Yeah.
Yeah.
In the spinal cord specifically.
Well, yeah. Or.
Yeah.
If you're asking whether one of us will be able to do that, it's unlikely. Whether we as humans will be able to do that, almost undoubtedly. There's nothing that we won't be able to do in terms of, realistic biology questions like that. It's a matter of figuring out all the chemical factors, figuring out a neat trick to, provide some sort of artificial scaffold that is made of some material that we haven't invented yet. But people are doing, inching along and doing stuff like that, week by week, day by day. And that's certainly something that's, I think, within the realm of feasibility in the next, 20, 25 years.
Okay. Due to the rise of Zika in multiple countries, what is the effect of microcephaly in the development of young children?
If we knew the answer to that, we'd be sitting on a podium much bigger than this, some other building somewhere.
We'd be swimming through a pile of money.
Yeah.
I'm not sure about this, but microcephaly is that the space for your brain to grow is reduced, and affects the cerebral cortex and especially the cerebellum. So for sure, your mental capability will be reduced, and I think your physical capability could be reduced to some degree. It depends.
Can I ask another question? Okay, it's another one about Zika. Sorry. So the virus, the way it causes microcephaly, as I heard, is it enters through the uterus and hits the fetus. So how would you prevent that from happening with a vaccination for it?
That is a very active topic that so many other scientists are working on right now.
Thank you.
So if I can just comment on that, the Zika example has been kind of interesting because it's one of the few cases where there was suddenly a new problem that needed to be addressed. And all of a sudden, labs that never studied Zika before started to study Zika because they realized it was important to be done. And usually, science operates really slowly. Usually, you propose some project that you want to do, and you usually get a grant that lasts about 5 years, but it usually takes about 3 or 4 years to write up the proposal and get that grant. And so you're proposing something that's going to take you 10 years to make a little, incremental step. Well, there are papers coming out weekly on Zika, and we've only even heard of Zika for less than a year. So we don't know those answers now, but it's an interesting example of, how it's kind of like a moonshot kind of thing, right? I wasn't around when it was decided, we need to send someone to the moon, we need to send them now. But Zika is kind of like that, and it will be an interesting test of how quickly we'll be able to get to the bottom of those questions as a field. And that's leaving the politics of, allocating money to that research sort of out of it, which is still another active area of ongoing effort.
Thank you. Could you please tell us your name and your school before you ask your question? That helps us. Yeah.
My name is Logan, and I go to American Heritage. My question is, have any of you ever studied Tourette Syndrome? And if yes, what did you find?
Not directly. So I think, I'm not an expert on Tourette syndrome. It expresses itself in a lot of different ways in a lot of different patients. I think there's a motor control component to it. I think there's probably a sensory motor control component to it. I've studied motor control and sensory motor learning, and I've studied movement disorders and in Parkinson and Huntington's patients. But I don't know that anything that I particularly studied would have, a direct relevance to that specific disorder.
Okay, and I have one more question, if that's okay. What do you think is the best route if you want to become a pediatric neurologist?
So I know one pediatric neurologist, and she has a great life, and she has seemingly had no problem getting to where she is in her career, and I can sort of recap what she did. She was educated at a music conservatory in Australia. She was a concert pianist, and then I think after she got that education, she went back and got her pre-med requirements met. So she took the classes she needed in order to basically apply to medical school. I think that getting into medical school is, the first big hurdle. So do really well in college. It's, getting into a great medical school is very competitive, but you can become a pediatric neurologist even if, you don't have to go to Johns Hopkins. You can go to another great, one of many schools. So I think that you just really have to focus on your studies and that sort of thing. I mean, I don't think there's any magic bullet to becoming something. You just have to know that you have to apply to college. You have to have certain requirements in order to get into med school, so that requires college coursework. Med school is its own, hall of a few years of classes and some interning and whatever they do. And then, I think you just keep moving from one step to the next. That one stage of education kind of leads into the next, and it's just I think once you get to each stage, it'll sort of unfold for you.
Okay, thank you.
Can you guys hear me? My name is Valencia. I'm from St. Lucius, and I wanted to ask why Max Planck? Like, what drew you to this specific institute? And for that, that's the first one. I had two actually. So, what drew you to Max Planck, if you will?
Yeah. So when I was looking for jobs, I was looking online, and there are a lot of different types of jobs that I was looking at. But Max Planck looked the coolest, definitely, first of all. So this is actually the only institute in the U.S., the only Max Planck Institute. So that alone is very special, and I'd heard of the Max Planck Institute before I actually heard about this position. So that was one of the reasons why. And also, there's so much incredible science going on here, and that I figured out after I applied, and I got even more excited about it. So that's sort of how I decided.
What's your next question?
And do you guys have any upcoming experiments or things that you guys can tell us about that could probably have to something we'd have to look into the future more about, if you will?
It's all top secret. I can sort of give you like the double answer to both of those questions that you asked. From my perspective, I came to Max Planck. I think that I don't want to read too much into your question. I think a lot of times you look for like the most, what inspired, a really big career choice. Because like choosing where to do a postdoc or be a grad student or be a core facility person or a faculty member is a huge choice. But never underestimate like just good timing. So when a lab has openings, that's super important. And a lot of really great labs are often at capacity. Like they just can't bring on new people. So you have to cast kind of a wide net, put out some feelers, and see who's hiring and who's doing stuff that you think is super cool. So it just happened that the type of stuff that I wanted to learn how to do in terms of the types of experiments I wanted to design and stuff, there was a lab here that was doing that with somebody whose papers I'd been reading throughout grad school and knew as just a top-notch researcher. So I think oftentimes there's a lot of options out there for the types of stuff that you want to do, but it's really just sort of narrowing down to like, it comes down to like kind of, just really simple decisions like where would be a cool place to live. When you meet the people in the lab, do you want to hang out with them every day? Stuff like that matters too. And then in terms of experiments, I think we are all involved in experiments every single day. I mean, I'm actually thinking about experiments that I'm in the middle of right now. So I think every day we're, I'm sure James and the people in his lab are working on a lot of really cool questions with astrocytes, and I'm trying to train animals to do like really complicated sensory tasks, and I think we don't necessarily know what the next experiment is going to be until we know what the current one, the answer to the current one is.
Thank you.
Hi, I'm Chase Brown from Suncoast, and I'm absolutely terrified of college. So my quick question was regarding college. Where would you look for like inspiration for what you want to do? Because I have a general idea of what I want to do, but I don't really know exactly what I want to do.
What's your general idea that might help?
Psychology is usually what I'm thinking. So
I would say try to find some sort of high school internship, maybe. That's one of the reasons why I got interested in biology. I was part of the biology club, and that's just a club, not even an internship. But that got me interested in biology.
But do you mean more like how do you choose a college or how do you choose a major?
Major.
Well, don't be afraid of college.
Well, like,
it's a lot of fun.
You said you found your inspiration through a teacher. Just like, is there any other ways I could kind of find fit best. like how I don't know. Like I have no idea what's gonna happen in life.
Yeah, nobody knows what's gonna happen.
Which is generally, you know.
So wait, so are you like a senior now?
Yeah, I'm a senior. It's not
And
fun.
you're looking at colleges, or
yeah, my main goal probably is just FSU for now because location and
cool
price.
Yeah. So well, that makes things easier if you know like geographically where you're going to end up. You can start. I mean, there's a lot of simple things you can do to sort of get acquainted with the different departments before you get there. Every department probably has a website where not only do they list all the faculty members on that website, in that department, but they probably have course listings. So you can sort of get a preview of the types of classes that you would be taking in certain majors. You might get a snapshot of the types of people that are working in those departments that would be teaching you. Things to think about are the types of classes that you're going to be taking. Are they big, auditorium classes where there's a guy giving a lecture twice a week for an hour and a half, or are they smaller, like 10-person, more like Socratic method type things where it's a lot of like discussion about readings and things like that, where everybody has a chance to talk and ask questions. And if you kind of know what your learning style is, or the environment that you would thrive in, and maybe that's the type of thing that maybe you kind of figure out in college. You can start to base some of your decisions that way. That would be my advice.
Your question is that you want to know how to choose a major, like between business and science, where
no, but in science, but like specifically more.
Yeah, I think you can take maybe some online one-on-one type of class, so you have a better idea like how many directions could be involved in that major, and also find someone who is already studying in that major. Like talk to us about neuroscience or biology, and we'll tell you what kind of options you probably will have. You can study animal, plants, neuroscience, cancer biology, and what are your expectations if you do really well in this field, what you can do in the future, and if you don't like it, what will be your other choice based on what you learn from here. So my suggestion would be to talk to someone already inside of that field.
I would also recommend.
I'll bring it back to the people and the mentors again. College is a little different than high school. You can just you can sit in on a class, right? If you're registered for Psychology 102 the first semester there, you can go sit in Psychology 103 and Psychology 104 just for a day, and you'll know right away that guy or that woman jive with me. I get along with them. I'm going to drop that other class and get into this class. You can really try out a lot of stuff, and if you get in a class and you hate it on day one, you're going to hate it on day 2 and day 3 and day 4, and you have a choice in college much more than in high school. So, take control and try something different.
Thank you very much.
Thank you. So in the interest of time, and given the line, let's maybe just one question per person from now on. And I don't know if I should have a timer for the panelists.
Yeah, right.
Maybe, yeah.
Hi, my name is Jacqueline Chen. I actually interned here, in Yasuda's lab in 2015, and after that, I had a lot of interest shifts. But I have one question that's directed towards Dr. Schumacher. Can you explain what functional architecture is and how that relates to neuroscience research?
Yeah. So functional architecture is trying to understand how a neural circuit is wired up in a way to perform some kind of function. So in terms of sensory processing, you might want to understand how a neural circuit is organized to represent the different types of sensory information. So one of the reasons you might know this term functional architecture is that one of the labs here is I think it's called something Lab of Functional Architecture. What we study is in the the visual cortex of certain animals, not all animals, the features of the visual world, like the orientation of edges in a visual scene, are encoded in columns. So specific sets of neurons are connected in a way that they all kind of share or lead to the expression of some kind of feature we call tuning. So some neurons might be tuned to horizontal edges, some neurons might be tuned to vertical edges, and if you look over the surface of the cortex, there's a really nice organization of how these different visual features map onto actual neural tissue. So the study of functional architecture is the study of how neurons give rise to a complex organization of something, basically.
Thank you.
Hi, my name is Seth Greenberg. I go to Bach Middle School of the Arts, and I was wondering, on behalf of middle schoolers and myself, I know that you can get an internship, and I know that during the summer you can go to camps for science and different types of science to really get interested in it. But as a middle schooler, what kind of camps or internships can I do?
Well, that's a good question, but probably it's for me. But here at Max Planck, it's true. It's only for high school students, given the responsibility and the maturity that you need to be in the lab. I actually don't know too many opportunities for middle school, except that I know about in terms of, well, it depends. I know about this really cool camp. It's a robotics camp for middle school students. It's in Boca, and some of the students that were interns here actually started this club, and it's you can do it as a camp over the summer. So if you're interested in robotics and using Legos and programming robots kind of thing, I know something that you can do in the summer. But in terms of science, there aren't too many things that I know about it. There's not, yeah, it's true. I can't think of too many things that middle school students can do, like immersive in the summer. So I'm really sorry about that. Sorry.
Thank you.
Hi, I'm Eli Weston from Suncoast. You mentioned there was a physicist who worked here, so what kind of connections are there between neuroscience and physics?
The physicist is my boss. So I think he had some sense of neuroscience when he take a summer course in Wuzhou, and many of the neuroscience development actually relies on the development of microscope. We see more, and we see them moving. We see live imaging, and that's how we know better about how our brain functions. And development of those type of microscope is a combination of physicists and neuroscientist knowledge. You need to know what you want to look at, and what type of technique is in desire, and how to develop those type of instruments to fulfill your requirements.
Hi, my name is Isabella Pearl, and I go to school at Turtle River Montessori. And my question is, what do you find is the most interesting thing about neurology?
So to me, what really keeps me invested in and engaged in is that it has a combination of these big picture questions that I mentioned before. How does our brain work? How do we have language? How do we have consciousness? How do we see? Which keep me motivated and interested and are fun to talk about when we're having a coffee and or having lunch. But then on the day-to-day, it's getting the microscope to work and futzing around with the optics, which is kind of fun. It's like tinkering around in your garage, and learning to do surgery. For some of our experiments, you have to learn to do surgery. You have to learn so many different things that every day, sometimes you're sitting at your desk. I had to learn to program, to do computer programming, to analyze data. So some days I'm doing computer programming. Some days I'm dealing with animals in the lab. Some days I'm writing, a proposal for a new idea that I have. And some days I'm sitting there thinking like, wow, the brain is so cool. How does it work? So it has all those levels that keep you engaged, at all different, all different areas of your brain.
Thank you. My name is Kevin, and I'm from Jupiter High School. And I was wondering if there's anything that any of you have done along your career education that you would have, going back, that you would have done differently, and whether or not you can share those.
So one thing I would have done differently is getting more hands-on experience. I did get hands-on experience, but if I could, I would get even more. Like they've been talking about, finding a mentor is extremely important, and then also getting the opportunity to work with that mentor is extremely important. So if you're working with someone for 3 years when you're in college, that's going to look really good, and you're going to get a lot of experience, and yeah, it'll put you in a good position.
Right, thank you.
Thank you. So we literally have about 5 minutes, and I actually wanted to take a few minutes to talk about our outreach programs. So I don't know if we can speed answer the last few questions. So let's give it a shot.
My name's Omar from Jupiter High. My question is, can memory be preserved through cryogenics?
Use the microphone.
I don't really know, but I think the problem is unfreezing. I think there's some species that you actually can freeze and unfreeze, like honeybees and stuff like that. And if you wanted to find a simple way to answer that question, I would look to those species. I'm not sure.
Thank you.
Thank you.
My name is Victoria Estevez, and I go to Forest Hill Community High School. And my question is, how can you apply your research to real-life diseases?
So, the emphasis of this institute is to not necessarily concern ourselves with that, and to only focus on basic research.
Which means
we just study the brain to understand how the brain works. And what we have is the hope that everything we learn can someday be applied to figuring out what got broken, why it's broken, and how it can be fixed. And basically, it's sort of the philosophy that if you don't know how it works, you can't fix it when it's broken. But to put a finer point on it, to give you a more real answer, is, for instance, I just alluded to these cells called astrocytes that we study in the lab. We study them because they're there and they need to be understood, and we're trying to study the basic properties of them. But with that said, there are a lot of indications that those are the cells that are going wrong in a lot of neurodegenerative diseases, in Alzheimer's disease. And so each little bit of information we can understand about how they work gives us another opportunity to observe what's going wrong in a disease like Alzheimer's.
Thank you.
Thank you.
My name is John Scott, and I go to Watson B. Duncan. And I wanted to know, how does being a neuroscientist affect your social life?
The ladies love it.
Well, your social circle shrinks a little bit. I think you spend so much time at the bench or at work that the people you start to commiserate with are people in similar situations. It helps to stay in touch with your friends from college who are off making money on Wall Street, because they'll occasionally take you out and have a good time. I don't think like being a scientist turns you into a shut-in or like a hermit or something like that. I think there's this thing called work-life balance, and I'm still trying to figure it out. But some people just have a way with making both of those things work out.
Thank you.
Hi, my name is Alat, and I was wondering why you were bad at school. Did your mom yell at you, or what happened?
I think that like early on, I was bad at school because I just wasn't inspired, and I think my parents understood that. They didn't like it, and they definitely crack the whip every so often. I wasn't bad at all school. Like I did pretty well in English classes and math classes, but science was a little bit just like I didn't really care that much. I think it's, if you have understanding parents, they know that you're still sorting out what you're actually interested in. And the thing that I think for me has been like the key to achieving anything is to really work at something that I'm really interested in. So
I also have a really quick question for Conan.
Yep.
What's up with the hair?
I don't know what is up with my hair. I don't know.
I think it's really cool.
Oh, thank you.
All right, thank you.
Thank you. All right, so I just wanted to, before we conclude, I had some flyers at the table that might be relevant to all of you. One is the Brain Bee Flyer, which is a neuroscience facts competition that happens in February. And it's a neuroscience, you compete in teams of 3, and you come here to the atrium, and you learn from an online study guide, and you win some prizes, and you get to tour MPFI, although you're going to tour it today. And then the other flyer is for our high school internship program that happens during the summer, and if you're selected, you get paid to do research. And actually, we have a special night tonight because we have some of our former interns in the house, and I thought it would be nice if you guys could just stand up. There's 4 of you, could just stand up, and I'm just going to quickly run to you with the microphone, and just so you could say, or if you can come up and you can just sort of say who you are, your school, and I don't know, what you thought was good.
Hi, my name is Carrie Raymond. I'm currently a senior at Spanish River High School, and I got to work in the Sam Young lab, which allowed me to understand the research process, and it was a wonderful experience because we got to shadow scientists and develop connections and kind of see if that's a career path that we want to take.
Thanks, Carrie.
Hi, my name is Hamani Gooby, and I go to Suncoast High School. I'm a senior. I think the internship provided me with a lot of opportunities to kind of experience the real scientific world and how research works, and develop a lot of connections with a lot of amazing people that I think I'd remember for a long time.
Thanks.
Hey, hi. My name is Jacqueline, and I go to Suncoast. I worked in the Yasuda lab in the summer of 2015, and I learned a lot more in the lab doing hands-on work than I did in school in the classroom setting, because honestly it makes you have to understand the concept while you're working, otherwise you can't explain what you're doing, and that doesn't look good. Also, the internship gave me a lot of insight on what I wanted to do, not necessarily neuroscience, and it helped me gain more knowledge about myself and my interests.
Hello, my name is Philip Taylor. I worked in the Yasuda lab this past summer, and I really enjoyed being in the amazing scientific environment being with real scientists. I think the best part for me was I was a scientific programmer in the lab, so I was given a project and I needed to essentially figure out the methods and the functionality of how to implement a specific idea and carry it out by myself, sort of a lesser version of what Dr. Schumacher was saying about your own project in grad school. But it was just really nice for me to be able to have my own direction towards going towards a goal with a mentor and being able to create a real solution to a real problem by myself. I'm a student at Oxbridge Academy.
All right, thank you so much. All right, so if we could just have a round of applause for the scientists.